Assalamu alaikum wa rahmatullah. Dear students, in this very lecture, we'll discuss an important topic that is rubbers. And here we have to discuss two important kinds of rubbers, that is natural and synthetic rubbers. But first we define chemically what is a rubber. In polymer chemistry, how we can define a rubber. Remember this point. We'll first, what is meant by rubber? It is a polymer. Rubber can be defined as a polymer. It means that rubber is a kind of polymer. But how we can define the rubber as a polymer which can regain its size and shape when the applied force. This is the definition of rubber. How we can define the rubber in the polymer chemistry? It is a polymer which can regain its size and shape when the applied force is removed. This is the definition of rubber in the polymer chemistry. The polymer which can regain its size and shape when the applied force is removed. It means that we have discussed it in case of elastomers. When the force is applied on elastomer, it can be stretched. But when the applied force is removed, it regains original size and shape. It means that rubber is a common example of elastomer. Is a common example of an elastomer. You have to mention this point. In the polymer chemistry, how we can define the rubber? In simple words, is the polymer which can regain the size and shape when the applied force is removed, or you can say ये जो rubber है, it is an example of elastomer. Remember this point. Now there are two kinds of rubbers. The rubber obtained from synthetic natural sources. That rubber is known as natural rubber. It means that there are two types of rubbers. First we define them, then we will discuss them in a detailed manner. Types of rubbers. The rubber obtained from you can say the first one, natural rubber. We have to discuss it. The rubber obtained from natural sources. The rubber obtained from natural sources like plants. Natural sources like plants is known as natural rubber. Simple definition of natural rubber. Remember this point. The rubber which is obtained from the natural sources like plants, it is known as natural rubber. Natural source here, it is plant. And that plant is known as rubber tree. We have to discuss in this very lecture, inshallah. The second, we have synthetic rubbers. In polymer chemistry, how we can define synthetic polymers? In the polymer chemistry? How we can define the synthetic polymers in the polymer chemistry? Remember this point. Synthetic rubber, it is the polymer prepared in the lab. This is the definition. How we can define the synthetic polymers in the polymer chemistry. Any polymer prepared in the lab. Synthetic means they are man-made. They can be prepared in the lab. Any polymer prepared in the lab, any polymer prepared in the lab and resemble with the natural polymer, with the natural rubber. It means that synthetic polymer, yes, you can say synthetic rubbers. How you can define the synthetic rubbers? Any polymer prepared in the lab and has properties similar to natural rubber is called a synthetic rubber. This is the actual definition of a synthetic rubber. You can simply remember the rubber prepared in the lab. The rubber prepared in the industries, or you can say in the lab, that is synthetic rubber. But how you can define it in the polymeric? Any polymer prepared in the lab and has properties similar to natural rubber. That polymer should have the properties similar to the natural rubber. That polymer will be named as a synthetic rubber. It means that as far as the rubbers are considered, there are two types, natural rubber, and we have the second type, that is synthetic rubbers. Now we will discuss these two types of rubbers in a detailed manner. First we discuss the natural rubber, then we discuss the second type of rubber, that is synthetic rubbers. First we discuss the first type, natural rubber. It is clear from the name, it is a natural polymer. Why it is a natural polymer? Because it is obtained from natural sources, from plants. It is a natural polymer. This is the first point you have to mention. It is a natural polymer. आपने अभी बोला है कि rubber, they are elastomer. They have great degree of elasticity. You can say it is a natural rubber with great degree of elasticity. A great degree of elasticity. It is a natural polymer. This is the first point. Second, with great degree of elasticity. That is, it is an elastomer. You can say it is an elastomer. Remember this point. Second, as it is clear, it is a natural polymer obtained from the rubber tree. Remember this point. It is obtained. First, we will discuss. We see how it is being prepared, how it is being obtained from the plant. It is obtained from latex. First, you should know what is meant by latex. Latex, ये क्या होता है? It is a colloidal solution, colloidal sol, meaning mixture, colloidal sol of rubber particles, colloidal sol of rubber particles in water. I will tell you what is meant by latex. Remember this point. It is obtained from latex. What is latex? It is a mixture of rubber particles in water. First, I will tell you how you can get this latex. You have actually a rubber tree. Remember this point, rubber tree. And the botanical name of rubber tree is Hevea brasiliensis. The botanical name of rubber tree is Hevea brasiliensis. Remember this point. When you cut the bark, the outer layer of this tree, that is bark, when you cut the bark, you get a fluid, and the fluid comes out when you cut the bark, and that fluid, it is known as latex. The fluid which is obtained by cutting the bark of the rubber tree, that fluid is known as latex. And what is latex? It is a colloidal sol. It is a mixture of rubber particles in the water. It means the water contains rubber particles. That fluid, that water containing the rubber particles, that is known as latex. In simple words, you have to remember, when you cut the bark of the rubber tree, you get a fluid. And what is the composition of the fluid? Rubber particles in the water. First we see then what is made, what are chemically rubber particles ये क्या होते हैं, but यहाँ पे आपको पहले याद रखना ये fluid क्या होता है, latex क्या होता है, rubber particles in the water. It is obtained from latex, colloidal sol of rubber particles in water, obtained from rubber tree. Obtained from rubber tree. Remember this point, rubber plant, obtained from rubber plant, yeah, tree. What is the botanical name of rubber tree? I have already mentioned it. It is Hevea brasiliensis. It is the botanical name of Hevea, this rubber tree, that is Hevea brasiliensis. It means that if you want to obtain the natural rubber, you have to cut the latex, you have to cut the bark of the rubber tree, you get a fluid, you get the latex, and from that latex what you can obtain? You can obtain the natural rubber. Now we will see chemically what is natural rubber. We will see what is chemically the natural rubber. Chemically natural rubber is, this is the point you have to now mention. Chemically natural rubber is a linear 1,4 addition polymer of, you can, natural rubber is linear, yeah, you can say natural rubber is polyisoprene. Chemically natural rubber is polyisoprene. This is the point you have to mention. Poly means many. Now you should know what is isoprene. ये isoprene क्या होता है? It is 2-methyl 1,3-butadiene. This is isoprene. Remember this one. Chemically, what is isoprene? 2-methyl 1,3-butadiene. Chemically, natural rubber is polyisoprene. Isoprene chemically it is 2-methyl. For example, you have this isoprene. This is isoprene. It is 1,3-butadiene. 1, 2, 3, 4. 1, 2, 3, 4. 2 per methyl है, then what will be the name? 2-methyl 1,3-butadiene. 2-methyl 1,3-butadiene. It is known as isoprene. When it because it contains double bond, it undergoes addition polymerization. When this isoprene is allowed to undergo addition polymerization, what you get, this form, it will form bond. Pi bond will shift here. It will shift here. It means that it will form bond. Pi bond will shift here. What you will have? You will have CH2. This one, single bond, CH3. This is the way. Then you have double bond. Then you have CH2. This is natural rubber, polyisoprene. This is isoprene. When it undergoes addition polymerization, you get polyisoprene. Remember this point. And this polyisoprene, it is natural rubber. Remember this point. And how it is obtained? It is a linear polymer. Remember this point. Obtained by 1,4. Carbon number 1 and carbon number 4 are involved in the polymerization. Hence, you can say it is obtained by the addition polymerization of isoprene, and it is a linear 1,4 addition polymer. It is a linear 1,4 addition. What is, remember, linear addition 1,4 addition polymer? Because carbon 1 and 4 are involved in the polymerization. You have to mention this one. Chemically natural rubber is polyisoprene. What is isoprene? 2-methyl-1,3-butadiene. यहाँ पे मैंने आपको दिखाया 2-methyl-1,3-butadiene. When it undergoes polymerization, you get polyisoprene. You get polyisoprene. And which carbon atoms are involved in the bond formation? Carbon 1 and carbon 4. Hence, it is a linear 1,4 addition polymer. Remember this point. You can say natural rubber is a linear 1,4 addition polymer. You have to mention this. First, you have to mention chemically natural rubber is polyisoprene. Isoprene is 2-methyl-1,3-butadiene. You can also say natural rubber is a linear 1,4 addition polymer. Around this point. What is meant by 1,4 addition polymer? Because 1,4 carbon atoms of isoprene, they are involved in the polymerization. Now I will draw the structure again to discuss certain important points. First, you have to take the isoprene. This is isoprene. CH2, double bond C, यहाँ पे CH3, यहाँ पे we have single bond CH, double bond CH2. This is isoprene. I am drawing the structure again. Isoprene n times. It undergo polymerization. Addition polymerization. It undergoes addition polymerization. What happens? Pi bond will shift from this to this. It will shift here. Valencies will be created at the terminal carbon atoms, and you will have CH2, CH3, double bond CH. You will have CH2. You will have N times. This is polyisoprene. Now you have to discuss, this is natural rubber. You can say it is polyisoprene. Now there are two important points you have to mention. Each repeating unit, this is the repeating unit, N times means this will be repeated. This is the repeating unit. It contains a double bond. In the 11th class, in geometrical isomerism, in alkenes, you have discussed an important topic, that is geometrical isomerism. I will give the idea. When the compound contains double bond, when the compound contains double bond, here we have the repeating unit, it contains the double bond. It can have two orientations. I will give the simple example. For example, you have double bond, you will have Cl, and you will have H and H. For example, this is the simple compound containing the double bond. It has two isomeric forms. When the similar groups are present on the same carbon, chlorine on the same side, hydrogen on the same side, it is known as cis form, or you can also call it syn form. Cis means same orientation. If you have this one now, chlorine, and we have the hydrogen and hydrogen. Now the similar atoms or groups are present on the adjacent side, on the opposite side. This orientation, this stereochemistry is known as trans form. Trans form is also known as antiform. Remember this point. You have to simply remember, when the repeating unit contains a double bond, it can have two stereoisomeric forms. It can have either cis orientation, it can have trans orientation. It can have same cis form, similar groups can be on at the same side, and trans form, the similar atoms or groups will be present on the opposite side. Same is the case here. Polyisoprene, there is double bond. It means that it can have two orientations, cis orientation, cis stereochemistry, or it will have trans stereochemistry. Stereochemistry is that branch of chemistry which deals with this orientation. Remember this point. But it has been experimentally found. This is the point you have to mention. In natural rubber, remember this point, all the double bonds have cis stereochemistry. It means that all the double bonds have which orientation? That will have the cis orientation. We will discuss this cis orientation in case of this. You have to remember here, first point, since each repeating unit since each repeating unit contains a double bond, hence it can have, double bond can have either cis or trans orientation. It can have either cis orientation, cis stereochemistry, or trans orientation. It can have cis orientation or it can have trans orientation. But what has been found in natural rubber, all the double bonds have cis orientation, as cis stereochemistry. It has been experimentally found that in natural rubber, this is the point you have to mention, in natural rubber, all the double bonds have cis orientation. Double bonds have cis orientation, or you can say stereochemistry. This is the first point. First, we have to mention simply, natural rubber is obtained from latex. What is latex? It is a colloidal sol of rubber particles in the water. Where from it is obtained? It is obtained from the rubber tree. What is the botanical name of rubber tree? Hevia brasiliensis. And chemically, what is natural rubber? It is polyisoprene. It is obtained by the polymerization of isoprene. What is isoprene? 2-methyl-1,3-butadiene. As soon as the repeating unit contains a double bond, what it means? It means that it will have either cis orientation or trans orientation. But what has been experimentally found, that in natural rubber, all the double bonds have cis orientation or trans orientation. We'll discuss this cis orientation. It will have cis orientation, or you can say cis stereochemistry. Now we will draw the structure of natural rubber to understand the cis stereochemistry. We'll write, this is polyisoprene. This is natural rubber, CH2CH. यहाँ पे methyl group है. Then we have double bond. Then you have CH3, CH2. This is natural rubber. Now we'll draw the structure. We have double bond. You can say here, you have CH, double bond CH. This one. 1, 2, 3, 4. यहाँ पे H नहीं है. This is the bit. यहाँ पे H नहीं है. CH double bond C, this one, draw it properly. You have C double bond C. This is the way. Now arrange the groups present on this carbon and this carbon. Here on this carbon you have one CH2 and CH3. You can say you have CH3, you will have CH3, this one, and you have CH2. It means that this is the stereochemistry on this carbon, CH3 and CH2. On this we have hydrogen and we have CH2. Now it is clear, since the like groups, methylene groups, CH2, CH, they lie on the same side. Like groups, they lie on the same side. It is cis orientation. Now this CH2, it will be linked to this CH2. CH2 again. This CH2 will be linked to CH2 of another repeating unit, that is CH2. This CH2 is attached to carbon. You have this methyl. This CH2 is linked to another monomeric unit, and another monomeric unit will be this one. We have CH, it is attached to CH2, it is attached to carbon, that is attached to methyl. You have double bond again. Then you have CH2, you will have H. Now it is clear, that here again the CH2 lie on the same side. Here CH2 lie on the same side. When the similar groups lie on the same side, this orientation, this stereochemistry is known as cis stereochemistry or cis orientation. Then which form of rubber it will be? It will be cis polyisoprene. It is polyisoprene. But what is the orientation? It is cis polyisoprene. And this cis polyisoprene, it is known as natural rubber. It means that all the double bonds will have, this is the double bond, cis orientation, because CH2 lie on the same side. This is the double bond, CH2 lie on the same side. We have another kind of rubber that is known as gutta-percha. Remember this point. I will talk about that very kind of rubber. You have another kind of rubber that is gutta-percha. Latin gita means gum and percha meaning plot. This is the point. Gita means gita. Gita means gum and percha means plot. In this gutta-percha, remember this point. How we can first define it? How you can define the gutta-percha? It is natural form of isomer of the rubber. Natural isomer of rubber, meaning that it is another form of this natural rubber, that is gutta-percha. The difference between this cis natural rubber and gutta-percha, here the orientation is cis orientation, cis stereochemistry, but in gutta-percha, remember this point, the orientation in case of double bonds, that is trans. It means this is the point, simple difference between the natural rubber and gutta-percha. In this type, all the double bonds have trans orientation. You can remember here in gutta-percha, it is another form of another isomer of this. In this type, all the double bonds have, you can mention here, all the double bonds have trans orientation. Stereochemistry. Have trans stereochemistry. Now you have to simply remember, cis polyisoprene, that is natural rubber. Trans polyisoprene, that is gutta-percha. Remember this point. In natural rubber, orientation is cis. In gutta-percha, another common isomer of rubber, natural rubber, that is gutta-percha, the double bonds have the trans orientation. Now we'll discuss the trans orientation in gutta-percha. Remember this point. We'll discuss it. Trans orientation in gutta-percha. You have this one, C double bond C. You will have CH3, you will have CH2. Now here on this carbon you have CH2 and we have H. Now what is clear? In this form, methylene groups, they are on the opposite side. It is trans orientation. It will be linked to another CH2, another monomeric unit, another repeating unit, and it will be attached to C double bond C, just like the cis form. But the only difference is here the orientation is trans orientation. Here it will be CH2, here it will be H, it will be linked here. This is the way. If you consider this double bond, CH2 on the opposite side. If you consider this CH2 on the opposite side, it means that it will be trans polyisoprene. And this form, trans polyisoprene, it is known as gutta-percha. It is common isomer of natural rubber, trans polyisoprene, gutta-percha. In simple words, you have to remember what is the orientation in the natural rubber. It is cis form, cis polyisoprene. And what is gutta-percha? It is trans polyisoprene. One point. This is the most important point about the orientation, about the stereochemistry in natural rubber. In natural rubber, the orientation, the stereochemistry is cis form, and in case of this form, this Gutta-Purcha form, the geometry, the stereochemistry orientation, that is trans orientation. Once point. Now we'll talk about the natural rubber. If you draw the natural rubber again, I will draw it again so that it will be very easy for you to draw it more and more. This is, here it is cis form because natural rubber is cis form. It is linked to CH2 that is attached to C double bond C. You have CH3, CH2, and you have H. It is methylene group is on the same side. It is cis orientation. If you look on this very structure of natural rubber, there are no polar groups. Polar groups means OH, del minus del plus NH, del minus del plus. There are no such polar groups. It means that the interaction between the polymeric chain, this is one chain, another chain, the interaction, intermolecular forces between the polymeric chains will be weak of the type van der Waals force. This is the first point. In case of natural rubber, now we are talking about the interaction between the polymeric chains because there are no polymeric polar groups plus and minus. As a result of this, the magnitude of intermolecular force between the polymeric chains, it will be weak of the type van der Waals force. This is the first point you have to mention. Since there are no polar groups, there are no polar groups in natural rubber. It's clear from the structure, natural rubber. Hence the magnitude of intermolecular forces. We have already discussed this on the basis of classification of magnitude of intermolecular interaction between the polymeric chains. They can be weakest type, they are elastomers. They can be strongest, that is fibers. We have discussed these things. There are no polar groups in natural rubber, hence the magnitude of intermolecular forces between the polymeric chains, polymeric chains will be weak of the type van der Waals. Weak of the van der Waals type. You know that type of polymer in which the magnitude of interaction between the polymeric chain is weak of the type van der Waals, that is the elastomer. We have already mentioned that natural rubber is elastomer. It means the interaction between the polymeric chain is weakest of the type van der Waals, hence it is an elastomer. We have discussed it. Now the question is, the second point is, the first is interaction is weakest of the van der Waals type. Second, the magnitude of interaction gets further decreased by the stereochemistry. It means by the cis orientation. It means that this cis form, this cis orientation does not allow the polymeric chains to come close to each other. It does not allow cis orientation because of this methyl group. They does not allow the polymeric chains to come close to each other. In other words, we can say the interaction between the polymeric chains gets further decreased by the cis orientation, by the cis stereochemistry. आपको याद रखना, पहले आपको बोलना है कि वहां पे पोलर ग्रुप्स नहीं है, इंटरेक्शन वीक है, ऑफ द वैन डर वाल्स टाइप है, मगर ये जो इंटरेक्शन है इट गेट्स फर्दर डिक्रीज्ड बाय द सिस orientation. You can say this important point here. This interaction gets further decreased. Interaction gets further decreased. This interaction gets further decreased. Further decreased by the cis orientation of double bonds, which does not allow the polymeric chains, to come close to each other, come close to each other, come close to each other. This is the first point, or you can say second or third point regarding the nature of polymer. There are no polar groups, hence the interaction between the polymeric chains weakest of the van der Waals, जो आपने elastomer में पढ़ा है. Now the second point is this interaction gets further decreased by the cis orientation, because the cis orientation cis stereochemistry does not allow the polymeric chains to come close to each other. Remember this point. Hence we can say natural rubber is an elastomer. Hence we can say, since the interaction is weakest, hence we can say natural rubber is an elastomer. Now you know the structure of elastomer, that is a coiled structure, not linear. आपने elastomer पढ़ा होगा. We have discussed this. Elastomer has a highly coiled structure, and when you apply the force, it gets stretched. When you remove the force, it regains its original form. We have discussed these things. Hence, we can say natural rubber is an elastomer with coiled structure, with a highly coiled structure, In other words, we can say that is elastic. In other words, we can say natural rubber is elastic in nature. Elastomer, we can say natural rubber is elastic in nature. I will repeat these points again. In natural rubber, there are no polar groups. There will be no strong interaction between the polymeric chains. There will be weakest interaction of the type van der Waals. And the interaction gets further decreased because of cis orientation, because of cis stereochemistry. Hence, the interaction between the polymeric chain is weakest. Hence, it is elastomer with highly coiled structure. You can also say the natural rubber is elastic in nature. Come on, this point. Now, if you talk about the gutta-percha, the orientation is transorientation. Remember this point. Transorientation. In gutta-percha, remember this point. The interaction is a little bit stronger than that of the natural rubber. Hence, that gutta-percha cannot be stretched a lot, cannot be stretched to a greater extent. In other words, you can say gutta-percha is non-elastic in nature. Natural rubber is elastic because of highly coiled structure. They can be stretched by applying force, but on the other hand, gutta-percha is non-elastic in nature because that cannot be stretched to a greater extent. You can mention this important point. On the other hand, gutta-percha, second type of rubber, gutta-percha is non-elastic. Natural rubber is elastic. This one is gutta-percha is non-elastic as it cannot be stretched. It cannot be stretched. It cannot be stretched to a greater extent. Actually, in gutta-percha there is zigzag. zigzag structure. There is not a coiled structure. There is a zigzag structure. If you have the text, you can find this structure there. Gutta percha has zigzag structure. There is not a coiled structure. Because of coiling, when you apply the force, it gets stretched. But when you have the zigzag structure, if you apply the force, it can be stretched, but a smaller extent. You can say natural rubber is elastic. Gutta percha is non-elastic in nature because of zigzag structure. Remember this point. This is the first point difference between the natural rubber and gutta percha. In natural rubber, it is cis polyisoprene. Gutta percha, it is trans polyisoprene. Natural rubber is elastic in nature. Gutta percha is non-elastic in nature. The third and last point you have to mention between these two kinds of rubbers, because of cis stereochemistry, because of cis orientation of double bonds, it cannot be packed close in a crystallites. It does not fit in a crystallites. From this point, it means that it is non-crystalline in nature. When it does not fit in a crystalline nature because of cis stereochemistry, because of cis orientation, it means that it is non-crystalline. And the gutta percha, because of trans orientation, that can be packed in a crystallites, that is crystalline in nature. 3 points of differences. Natural rubber, cis polyisoprene. Gutta percha, trans polyisoprene. It is elastic in nature. It is non-elastic in nature. And now we have to discuss the third point. Due to cis orientation, natural rubber does not fit in a crystallites. आपने solid state में पढ़ा होगा. Does not fit in a crystallites. Hence, it is non-crystalline in nature. It means that arrangement is not regular throughout. Crystalline means when the arrangement is regular throughout. But because of this cis orientation, the repeating structures cannot be packed regularly throughout. Hence, it is non-crystalline in nature. Hence, it is non-crystalline in nature. This is the first point you have to mention. Third point of difference, due to cis orientation, natural rubber does not fit in a crystallites, hence it is non-crystalline in nature. On the other hand, gutta percha fits in a crystallites, or you can simply remember, on the other hand, gutta percha fits in crystallites because of trans orientation. Crystallites, you have to mention it. On the other hand, gutta percha fits in a crystallites because of trans orientation. Hence, it is crystalline in nature. Hence, it is crystalline in nature. These are the 3 important points of difference. First, you have to remember the natural rubber. It is a natural polymer with high degree of elasticity. Where from it is obtained? From the rubber tree, Hevia brasiliensis. Chemically, natural rubber is polyisoprene. And the double bond has which kind of orientation? Cis orientation. When it has trans orientation, at that time it is known as gutta percha. 3 points are difference between these two kinds of rubbers. Natural rubber, and it is elastic, that one is non-elastic. It has cis orientation, that has trans orientation. It is non-crystalline in nature. Gutta percha is crystalline in nature. And inshallah, in the next lecture, we will discuss the problems associated with the natural rubber. What kinds of problems are associated with the natural rubber? Because of double bond, I will mention 2 points. It is being a double bond is an indication for instability, reactivity. Because of double bond, it is being readily attacked by acids. it is being attacked by bases, it is being attacked by oxidizing agents, it is being attacked by reducing agents. Because of double bond, it has great tendency to absorb the water. Remember this point. It means that because of presence of double bonds in the natural rubber, it has many problems. The first, it is attacked by acids, bases, oxidizing agents, reducing agents. The double bond can break. If you have double bond, it can break. Water can add. If how the water adds H plus and OH minus, H plus can go here, OH minus can go here. It means that because of double bond, natural rubber has great degree to absorb the water. Moreover, when the temperature gets increased, its elasticity gets increased. It means that there are a number of problems associated with the natural rubber, hence it cannot be used as such. First, we have to overcome these problems. Acids should not be attacked, bases should not be attacked. Attack of oxidizing, reducing agent should be hindered. It should not absorb the water. We have to overcome, we have to maintain its elasticity. To overcome these problems associated with the natural rubber, we have an important property, we have an important topic, that is vulcanization of rubber. And vulcanization of rubber is to maintain the elasticity of the natural rubber, is to overcome these problems associated with the natural rubber. Inshallah, in the next lecture, we will discuss an important topic, that is vulcanization of rubber. But you should here remember, the main aim of vulcanization of natural rubber is to maintain its elasticity, to overcome these problems associated with the natural rubber. And this is the important topic. Inshallah, we discuss this important topic in the next lecture. Till then, fi amanillah.